Hello everyone and welcome to MV Tutors. I'm Silo and I'll be looking at the Maths Paper 1 Prelim paper written in Gauteng. Okay, so yeah, we have 3 hours, 150 marks. So without wasting any time, let's go to question 1. And while we're at it, please don't forget to like our videos as well as subscribe to our channel. I hope you've been doing good. It's been a minute, but we're back. All right. Okay, so question 1.1 to be specific. So given we have that 2k is equal to x minus 5 multiplied by x minus k. Okay, so this time they're doing things a little bit different. All right, then let's see how or what they want. So determine k if x is equal to 2. Okay, that sounds doable. So if x is equal to 2, we're just going to substitute 2 wherever we see x. And then we're just going to solve, right? So 2 minus 5, that's just negative 3. And then we have 2 minus k. So we're just going to get rid of the brackets, bring the 2k to the other side, or we'll just see. We'll see how it works out. So negative 3 times 2 is negative 6, and then we have positive 3k. All right, so what I'm going to do, I'm going to take the negative 6 to the left-hand side so that it becomes positive. And then we have 2k coming onto the right. So that will be 3k minus 2k, and that's just k. All right, so therefore k is equal to 6. And that is what? 2 marks. Yeah, as expected. It was a straightforward question. And now they say determine x if k is 2. So now we have 2 times 2 is equal to x minus 5 times x minus 2. All right, so we have 4. And we're just going to get rid of the brackets. So we have x squared minus 5x minus 2x and plus 10. So if we bring the 4 to the other side, we have x squared minus 7x, and then it's going to be 10 minus 4, which is 6, positive 6 that is. And we're just going to factorize, so we have x. So 6 plus 1 will give us 7, right? Minus 6 minus 1 to be specific will give us minus 7. And minus 6 times negative 1 is positive 6. So basically, x is equal to 6 or x is equal to 1. Okay, and that is how you get the 4 marks. Now we go to our regular questions that we are accustomed to. So for 1.2.1, solving for x, we have 2x squared plus 3 is equal to 8x. So as soon as you see correct 2 decimal places, you know we will be using the quadratic formula. Okay, so we have 2x squared minus 8x plus 3, and that is going to be equal to 0. So if we use the quadratic formula, it's going to be x is equal to minus b. So minus, and b in this case is minus 8. Minus b plus minus, and then in the square root we have b squared minus 4ac. So b squared minus 4a times c. Remember, it's all under a square root, and all of that is divided by 2a. All right, so at this point, you can plug it as it is into the calculator, or you can simplify it for yourself. Maybe let's simplify it a little bit. So we have 8 plus minus, and then we have 64 minus 4 times 2 is 8 times 3 is 24. All right, and that's all over 4. So I think here we can employ our calculator and just work it out. So x is equal to something, or x is equal to something. So we have our fraction over there. So 8, I'm going to start with the positive. And then we have 64 minus 24, and that's all over 4. Ooh, why do I keep clicking on Lin? So we have x is equal to 3, 5, 8. Yeah, they did say round off to 2 decimal places, right? Then we're gonna have 8 minus. Okay, so we have our answer there as 0.42. So ladies and gents, so far it's okay, right? We are coping. 1.2.2, we're still solving for x. So question 1 really is the place where you should be collecting your marks. All right, here you shouldn't be messing up things unless if you make a stupid error or a silly mistake. Yeah, let me not say stupid. Okay, so then we have that. All right, so before we even take away the square root, I would suggest that we take the 10 to the other side. Okay, so we have a minus 10. When you take it to the other side, it will be a plus 10. And minus 12 plus 10, it will be minus 2. Okay, so basically I'll have x minus 2. And in order to get rid of the square root, I'm going to have to square both sides. So then I'm left with 2 times x plus 10, which is equal to, if I say x minus 2 squared, I'll basically have x squared minus 4x plus 4. All right, let me just take out the brackets on the left-hand side. So basically I have 2x plus 20 is equal to x squared minus 4x plus 4. Then I'm going to take everything to the right-hand side. Okay, so x squared is fine. Then we have minus 4 minus 2x. So that's basically going to be negative 6x. And if I say 4 minus 20, I will then have negative 16. Now I need to ask myself, what will give me negative 6 as well as 16? So 2 times 8, right? That gives me 16. And if I say minus 8 plus 2, that will give me minus 6. Okay, so basically x is equal to negative 2 or x is equal to 8. But, let me test the solution of negative 2. Whenever you have a square root somewhere, it's always best to check, all right, if the answers that we're getting actually do work. So if I have here 2 times negative 2 plus 10, and that's all under square root, minus 10. Okay, this is the left-hand side. And then on the other hand, I have the right-hand side. So I have minus 2 minus 12. So minus 2 minus 12 will give me minus 14. And then on the other hand, I'm just going to, because I'm checking, I just want to do this as quickly as possible. So 2 times minus 2 plus 10, that will give me 8. Okay, and then I have minus 10 over there. So I have negative 6. So clearly, x is not equal to 2. Now, is x equal to 8? Probably. I've never come across a scenario where both of them are not equal, but it's good that we check, right? So let's check if we have the 8, what answer we'll get. And then on the other side, we have x, which is 8 minus 12. So 8 minus 12 will give us minus 4. And here, if we say 2 times 8 plus 10, that's 18. I get minus 4. So indeed, x is equal to 8, but x is not equal to negative 2. Great. Now we can move on with confidence. All right, so 1, 2, 3. We have 3 to the power x multiplied by x minus 5, and that is smaller than 0. Okay, so when you get to these kinds of questions, just look at the mark allocation. It's 2 marks, so really you shouldn't be laboring much. All right, so we're going to take this 3 to the power x and have it smaller than 0, or x minus 5 is smaller than 0. Now, if you think about this function, the exponential function, it looks something like this. Okay, and as such, if they say where is 3 to the power x, which values of 3 to the power x are actually smaller than 0? We don't have it. If it's smaller than 0, it should be in this region, but we don't have a solution there. So in this case, you can safely say that there is no solution. Okay, and on the other end, we have x minus 5 is smaller than 0. You can take the minus 5 to the other side, and so x is smaller than 5. And that's where you ended. That's where the 2 marks comes in. All right, so we're done with 1.2. Now let's go to 1.3, solving simultaneously. Fun question to gather your marks if you do not make silly mistakes. All right, so we have 3 to the power x, and it's rooted, multiplied by 9 to the power y is equal to 27. And we also have that x plus 4y squared is equal to 6. All right, so how are we going to solve this? I can see that 3 to the power x, basically, I can see that this first equation can be written with the base 3. Okay, so I'm going to actually leave 3 to the power x, and I'm going to take 9 to the power y on the other side by dividing, right? So I have 27, which is 3 to the power 3, and I have 9 to the power y, which can be written as 3 to the power 2 times y. All right, and as such, I can then take the square root to the other side. So I have 3 to the power x, and if I take the square root to the other side, I'm basically going to square both sides. All right, so in my numerator, the 3 times the 2, remember, if a power is raised to a power, we multiply it. So 3 times 2 is 6, and then we also have 2y times 2, which is 4y. All right, and on this end, I'm just going to say x is equal to 6 minus 4y squared. Okay, this is actually my second equation. Let me simplify this equation further. So I have 3 to the power 6 minus 4y. Remember, if you have the same base and you're dividing, you must subtract the exponents. Okay, so because I have the same base, I can then say x is equal to 6 minus 4y. Okay, and that's my first equation. Sorry, that's my first equation. So I'm going to substitute my second equation into my first equation. So basically x, I know that x is 6 minus 4y squared, and that's equal to 6 minus 4y. All right, I see, let me just put it there. I see that the 6's can actually cancel out, and I'm going to take 4y squared to the other side. Negative 4y squared, which then becomes 4y squared minus 4y, and I can see that 4y is actually a common factor. So I'm left with y minus 1. Actually, I should have just gotten rid of the 4. Divided both sides by, yeah, it's okay. It's okay. Let's just do it this way. So 4y is equal to 0, or y minus 1 is equal to 0. So basically y is equal to 0. That's my first solution. And we have that y is equal to 1. That's the second solution. And then you can substitute these values in any equation. So I'm going to substitute the y values into my first equation. So x is equal to 6 minus 4 times 0. So where y is 0, x is equal to 6. And where y is equal to 1, x is going to be equal to 2. So those are my solutions for the x and y. All right, so we're done with 1.3. Now let us go to the last question, 1.4. It says the solutions of a quadratic equation are given by that. All right, x is equal to negative 2 plus minus, and then the square root of the discriminant over 7. Now it says, state the value or values of p for which this equation will have two equal solutions. So here, this is where you should know the properties of the discriminant and the different conditions that apply. All right, so basically, if we want two equal solutions, remember, this is for a quadratic equation or parabola. If you have a turning point on the x-axis, then you have two equal solutions. Basically, your discriminant is equal to 0. So what is the discriminant? It is whatever it is under the square root. So what is our discriminant? We have 2p plus 5. So 2p is negative 5. P then would be minus 5 over 2, or just simply negative 2.5. It's really up to you how you write it. But yeah, this will do. And then 1.4.2, it's as if it does not have real solutions. When will a parabola not have real solutions? Well, basically, if you have no intersection with the y, with the x-axis, there are no roots. Okay, so your turning point is somewhere above the x-axis. That is where you will not have real roots. Okay, it can be here, it can be this side. I just choose to put it in the first quadrant. So, ooh, now these look like two boobs. Anyway, no real solutions. Basically, your discriminant, whatever is under the square root, is smaller than 0. Now, you know, if you have anything smaller than 0, you will, if you plug that into the calculator, it will tell you no solution or math error. Okay, but anyway, here we are. 2p plus 5 is smaller than 0. So 2p is smaller than minus 5. Again, similar solution. So p is smaller than negative 5 over 2. All right, so question 1 actually went quite well. This is a prelim. I'm expecting tricks and hard questions, but so far, so good. Okay, now let's go to question 2. All right, so it says, given the quadratic sequence, so it has been given over there. I think let me just write it down nicely for us so that we can see what's actually going on. So we have 0, 5, 14, and then we have some terms that are there until we get to 7, 7, 9, and 8, 60. Okay, they told us it's a quadratic sequence, so I am just going to go ahead and see what's actually going on there. All right, and then here we have 9. Let's just say the next term is x, and then we have y, and then we have z, and blah, blah, blah. So yeah, I just need at least 4 terms so that I can see what's going on in this trend. So we have x minus 14. I actually just want to know what the common difference is actually. So to get to 9, we need to add 4. We know that it's going to be 4 ultimately. Okay, so let's get to question 2.1.1. Write down the value of the 4th term of the sequence. Okay, so here if I want to know the 4th term, I've named my 4th term x. So I'm just going to say x minus 14 minus 9 has to be equal to 4. Okay, so you know I take term number 3, subtract term number 2, and then that's equal to the common difference there. All right, so I'm gonna say minus 14 minus 9, and okay, let me just bring the 4 this side. Actually, yeah, I'm making too much work for myself. Okay, anyway, minus 14 minus 9 minus 4 is, so minus 14 minus 4 is minus 18, minus 9, that's minus 27. Yeah, I should have just actually taken the numbers to the other side. So basically, our 4th term is 27. And that's probably 1 mark, ne? Yeah. Okay, 2.1.2, it's okay even if we labor, that 1 mark will make a difference. So now 2.1.2 says determine an expression for the nth term of this sequence. So if I'm going to look at the nth term, my focus is the first diagonal. What do I mean by that? So firstly, we're going to start with 4. So 2a will be equal to 4. Now a is 2. Then 3a plus b will be equal to 5. So 3 times 2, remember we have 2 here. 3 times 2 is 6. And if I take 6 to the other side, it will be 4 minus 6, which is minus 2, right? No, why did I say 4? My bad. Not focusing here. And I actually underlined the 5. Anyway, so we have 5 minus 6, so b is equal to negative 1. And then finally, a plus b plus c will be equal to 0. I hope I write 0 and not any other number. So a, we know it's 2, b is negative 1, and we have c. So 2 minus 1 is positive 1. If we take it to the other side, c will be negative 1. Now we can write our equation. Tn is equal to 2n squared minus n. There's no need to write the minus 1 times n, okay? And then minus 1. What I like doing, as soon as I get my equation, I just want to see if I'm looking for the third term, okay, will I get the answer? Minus 3 minus 1. 14. Was the third term 14? Yes. There we go. Let's see the fourth term. Let's check our answer. Out of interest, what do we get? 27. So we know that that 1 mark that we worked so hard for is actually correct. Great. And now 2.1.3. It says calculate the number of terms in the sequence. Okay. So yeah, you can do it in different ways. Let's just see. Okay. There are many ways of actually doing it. You can look at the TN formula, the quadratic formula, or you can look at the arithmetic sequence, okay? And for that, actually, the last term for the arithmetic sequence, that will be 860 minus 779, which is 81. Okay, I'm going to go with the arithmetic sequence. So my last term is 81. My first term is 5 for the sequence. Okay, so if I look at the TN formula for the arithmetic sequence, so my first term is 5. I don't know how many terms there are, and the common difference that we have there is 4. And the last term there is 81. Okay, so I'm just gonna say 81 minus 5 is equal to 4n minus 4. So 81 minus 5 plus 4 is equal to 4n. 4n is actually equal to 81 minus 5 plus 4, which is 80. And n is equal to 80 divided by 4, 20. But we are not done. So they didn't ask for the number of terms in the arithmetic sequence. They asked for the number of terms in the quadratic sequence. So if I have 20 terms for the arithmetic, it means I need to add one more in order to find out how many terms I have in the quadratic. All right, like for example, if I have 4 terms here, on the arithmetic, I will have 3 terms. Okay, so here I have 20 terms for the arithmetic, meaning for the quadratic sequence, I actually have 21 terms. Okay, I chose to deal with the arithmetic because it's easy. I probably don't have to use the quadratic formula, but if you decided to go, like I said, that there are many ways of doing this, I decided to go with this way. If you decided to go with this way, for the quadratic pattern, you would have taken your term formula there, and then made all of this equal to 860, and then solved for n, okay? And let's just check. Okay, you don't have this calculator where it can solve for you, so don't stress. I just want to check my answer. It's beneficial to have a calculator that can actually solve, but I don't think it's allowed for the majority of you guys. So Yeah, actually, I don't think it's allowed at all. Okay, so shift mode, no. Shift second. Okay, no. I think I forgot how to actually get to the solving. Okay, let's just say we have 2x squared minus x minus 1, and we make that equal to 0. And then we say shift solve. Okay, no, I must make that equal to 860. Equal to 860, shift solve. So we have, yes, we have 21. X is equal to 21. So yeah, there are 21 terms. That was a very quick check, but you can use the quadratic formula in order to solve. All right, and then now let's go to 2.2. So it says, determine the sum of the whole numbers between 100 and 1,000, which are divisible by 11. Oh my gosh, okay. So from 100, there are many terms here, all the way to 1,000. Okay, what am I going to do now? I'm going to say, so 100. If I look at the multiples of 11, right? Let me start by actually saying 11 times 9. That'll be 99, obviously, so it's just before 100. If I say 11 times 10, so after 100, I'm going to have 110. 110, and then plus 11, I have 121, plus 11, I have 132, plus 11, it's 143. Okay, and we go on and on and on and on until we get to a number close to 1,000. So I'm just going to say, what is 1,000 divided by 11? It is 90,9. So 91. Let's just say 91 times 11. I get 1,001. So if I say 90 times 11, it's 990. So I have 990 before I get to 1,000. All right. So this is how the trend goes. But now I need to then determine how many these terms actually are, because that's what they're asking. They want to know the sum of the whole numbers between 100 and 1,000. So my thing here is I want to know how many terms there are first and foremost. And then after finding out how many terms there are, I'm going to add those terms by using the sum formula. Now remember, here the common difference that we have, we keep adding 11. Okay, so D here is actually 11. This is an arithmetic sequence. I hope that you see, but because we're going to add ultimately, it will turn into an arithmetic series. All right, so I have then my common difference, which is 11. What is my first term? My first term will be 110, because these are the numbers we're actually considering. Okay, we can't include 100 because it's not divisible by 11. So my first term is actually 110. And my last term is 990. Okay, so using the arithmetic sequence formula, okay, this is it. So Tn, that will be 990. My first term is 110 plus n minus 1. Please, I think if you're in a jam and you don't know what to do, I would say, yeah, but when are you going to finish? If you're going to say 110 plus 121 plus 132, it's going to take you forever if you're going to do it manually. So yeah, just think about it a bit, and then you'll hopefully, yeah, solve it and know what to do. Okay, so n is what we're looking for, and D is 11. All right, so we have 990. I'm going to take 110 to the other side, so I'm going to be left with 880, right? And then I have 11n minus 11. So if I take the negative 11 to the other side. So 880 plus 11, that'll be 891. I hope I'm not making any error here. And so basically n will be equal to, if I say 891 divided by 11, that is 81. Okay, so I have 81 terms. That helps me because now I can go to my series formula, okay, for arithmetic sequences. Now there's this long formula, 2a plus n minus 1 times d, or there's a short formula. You'll see which one is applicable and then we'll use the simplest one. So your first term and your last term. So do I have the first term? Yes, it's 110. The last term, it's 990. And I have the number of terms, so I'm going to go with the easier one. Yeah. We want to save as much time as we can. So we have 110 as our first term and our last term is 990. Okay, and then we can solve. So what do we have? We have 81 divided by 2. And then we're going to multiply it by 110 plus 990. And there we go, 44,550. For those who didn't trust this formula, you could have said if you're using the long one, 81 over 2, then your brackets there, you have 2 times a, which 2 times 110, plus n, which is 81 minus 1, multiplied by d, which is 11. Yes, getting the same answer. Oh, okay, for a while there I was like, is this correct? Okay, now let's go to question 3. All right, so given the geometric sequence, I'm just going to write it down for myself so that I can make my notes and see the trend. So we have a squared there, and then we have 4. So x minus 2 to the power 3. Okay, so this is decreasing. Well, that increases. Okay, 2. And then we have x minus 2 to the power 4. And so on and so forth. And they tell us x is not equal to 2, or else there's, yeah, everything will be 0. Okay. So what is the trend that I'm seeing? I'm actually multiplying by a half to get to the next term. And here I'm actually multiplying by this term, x minus 2. Okay, so that's basically my common ratio. And you can see same thing here. From 4 to 2, I multiply by a half. And then x minus 2 to the power 3. Coming to x minus 2 to the power 4, I multiplied by x minus 2. So now I have my common ratio there. Okay, so what is the question saying? So 3.1.1 says, determine the values of x where the sequence converges. Remember, the condition for convergence is that your common ratio should be in between -1 and 1. All right. Yeah, or else it doesn't converge. It will diverge. It will become bigger and bigger. So now we have our r, which we worked out as we were evaluating how this geometric sequence is working out. So r, common ratio, is a half times x minus 2, and that's basically in between -1 as well as 1. So if I multiply by half, multiply by 2 throughout, I have -2. Or you divide by a half, whichever floats your boat. So we have x minus 2 in between -2 and 2. And if I take -2 to the other side, it becomes a positive. So here we have 0. And if I take it to the right hand side, it will be 4. So this is where my solution lies, where the value for x where the sequence converges. And our 3.1.2, it says determine the sum to infinity of the series if x is equal to 2.5. So you go to your formula sheet if you have forgotten, and the sum to infinity is a over 1 minus r. Okay, so they told us that x is 2.5, so that helps. the first term is 8 times x minus 2. So 2.5 minus 2 to the power 2, right? Yes. And then our common ratio is a half x minus 2. So again, 2.5 minus 2. I am going to put all of this in a calculator, okay, because we are really trying to save time as well. So we have 8 times 2.5 minus 2, that's just 0.5 that's left, and that is squared. And in the denominator, we have 1 minus 0.5 multiplied by, again, 0.5. And we see our answer there is 8/3, or 2.67 if we round it off. Okay, so that is the sum to infinity. And the 3.2, so we are given k is actually equal to 3. For once, we're not starting at 1, but we're starting at 3. Okay, so we can see here this, if your unknown is an exponent, then this is a geometric series. Okay, 3.2.1, it says how many terms are there in this series. So if you want to know the number of terms, which is n, you take your top value, which is 12, you subtract the bottom value, which is 3, and you add 1. Okay, so 12 minus 3 is 9, plus 1, that is 10. Okay, 1 mark? Yep. And then 3.2.2, calculate the sum of the series. Okay, so we know that it's a geometric series, okay, and the sum equation for a geometric series is a r to the power n minus 1 all over r minus 1. So what do we know? So far we know what n is, but do we know r? We don't. Do we know a? We also don't know it. So let's go and get the first term, which is actually a. So you're going to take your formula, which is 3 times negative 2 to the power k minus 2. So what do we substitute in k? Are we going to substitute 1? No, we're starting with 3. So we're going to substitute 3. Okay, so we're going to say 3 minus 2. So that is our first term. And then our second term, we're just going to continue counting from then on. So the next term is 4. And then the third term will be 5 minus 2. So let's just get all of these. You just need 3 terms, okay? And then you're good to go. So 3 times negative 2 to the power 1. I'm just going to put it like that. 3 minus 2. So we get negative 6 as our first term. So now we have a. And then let's get the second term, 4, which is 12. And then just to be certain, let's get the third term, so 5, so that's negative 24. Now for me to go from minus 6 to 12, well, 12 divided by 6 is 2, right? And then there's that negative, so I have negative 2. And again, from 12 to 24, I multiply by 2, and then there's that negative. So we now have r. Okay, so we have everything now to actually solve this question. So a, like we said, is minus 6, r is minus 2, n is 10, minus 1, and that's all over r, which is minus 2, minus 1. Again, put this all in the calculator. Let us work to save time. So we have minus 6 multiplied by minus 2 to the power 10, minus 1. Yes, just be careful with the calculator there. Minus 2 minus 1, that's minus 3. And we have our answer there. It's 2046. So yeah, that's it for question 3. All right, question 4. So we have the graph of f of x, which is equal to ax squared. All right, and we see that they've actually drawn half of it. It's a quadratic function that passes through the the origin. So there's nothing funny there, straightforward. Okay, and then they also gave us a point P, which lies on the graph. So 4.1. By the way, how is the paper so far? I'm finding it to be a breeze at this point. Okay, so calculate the value of A. I would like to know from you how you are finding it. Yeah, so in this case, I'm just going to use y is equal to ax squared. And I'm going to look at my point, which is minus 6 minus 8. Then I will substitute it so that a is my only unknown. So I have minus 8, a minus 6 squared. So minus 8 divided by minus 6 squared, which is basically 36, is a. And I am expecting a to be negative, by the way, because it is a sad face parabola, half sad face parabola. So minus 8, I just want to simplify it over 36. That's basically minus 2 over 9. I'm not going to put in the decimal option. Okay, this will be fine. Okay, so basically f of x is equal to negative 2 over 9 x squared. And now 4.2 says determine the equation of the inverse of the graph. Okay, so if y is equal to negative 2 over 9 x squared, if I need to get the inverse, I'm going to swap the x and the y. Okay, and then put it in terms of y. So y squared will be 9 over 2 x, all right? And then I'm going to have a square root over there. By the way, this inverse, yeah, I'm looking at the question there. We're gonna sketch it at some point. But if we have our line y is equal to x, if your graph is like this, then the inverse will be like that. Okay, so I'm saying this because y is equal to, sometimes you could say plus or minus, but in this case I'm just going to say let's leave it as negative 9 over 2 x, well, square root. Okay, square root of negative 9 over 2x. Okay, yeah, and then 4.3, it says write down the range of the inverse. Okay, so the range of the inverse, it's actually the same for the original function. It starts from the negative infinity and goes all the way to 0. All right, so we're just gonna say y is an element of negative infinity to 0, and 0 is included, or you could say y is smaller or equal to 0. It's really up to you. It's 1 mark probably, yeah. Okay, and then 4.4, sketch the graph of the inverse. Indicate the coordinates of any point on the graph different to 0, 0. Okay, so this is our graph over there. So our original, I'm just going to put the line y is equal to x. I don't know if this will plot nicely. Hopefully it does. No, it didn't. Okay, so let me just do it like this. Let's just pretend this is our line y is equal to x. So the original function looks something like this. All right, let me just put this there. And then our inverse, I'm going to use a different color there. Our inverse, I'm just going to use purple. It looks like this. Okay, I tried. Anyway, so if our point P was somewhere there, where we have minus 6, minus 8, our point P prime will be minus 8 and minus 6. Okay, so that's it. They only wanted any other point except the origin. Okay, and then 4,5. Ooh, let me just change back to my favorite blue color. Okay, 4,5 says determine the equation. No. The graph of f is reflected across the line y is equal to x. So this is where we are, y is equal to x. And thereafter, it is reflected across the x-axis. So if it's reflected across the x-axis, remember this is the x-axis. So basically now we are here. Let me use a different colored pen. I didn't give myself enough space. But basically, we're there now. Okay, let me try to actually have it look. Yeah. So basically, there we are, right? For those who are visual learners, who want to see how this function actually looks. So again, we have a reflection about the x-axis. So now determine the equation of the new function. Remember, we go from this negative 9 over 2 x, which is square rooted. All right, this is where we go, and now the new equation will be y. Let me actually do that so that we're not confused. Okay, now the new equation in the form of y is equal to, because we're going, or we are reflecting about the x-axis, y becomes negative. Okay, but we can't have that. We want y alone, so we take the negative to the other side. And there we go. That's our equation. Oh, another thing. We have a square root. Okay, yeah, we have a square root, so you just need to make sure that x actually is smaller. Because of this negative, we need to make sure that x is smaller and equal to 0. Okay, so that you don't have math errors. So even here, again, x has to be smaller and equal to 0. And we are done with question 4. Now, question 5. So the point P lies in the Cartesian plane. Okay, that looks like it lies in the first quadrant. Okay, so let's just say maybe it lies somewhere there. That's point P. Now determine the coordinates of the image of point P if P is rotated about the origin through 90 degrees in an anti-clockwise direction. So if this is P, now through the origin we go 90 degrees. Okay, so now P is there. That's the reflected part of P. Now what is the coordinate? Okay, so if we have a reflection and it's anti-clockwise, right? Yeah. If we have a reflection about the origin 90 degrees in an anti-clockwise direction, so if this is your coordinate, the change then, first of all, the x and the y swap. Okay, and the y gets a negative. So if you had 2 and root 3, okay, it's one of those things where you need to know the rules. Okay, so reflections, but now this is a rotation. So rotation about 90 degrees or 180, please make sure that you know them. So here negative y will be negative root 3 and x is 2. So this would be your answer. Okay, and then this is 5.1. 5.2, the graph of h of x is equal to a to the power x. So this is your exponential function. And they're also giving you a point A. Okay. Now it says, substantiate y, the coordinates of Q the y-intercept of h are 0 and 1. Okay, so if you have a y-intercept, so for the y-intercept, x has to be 0. Okay, and if your equation is a to the power 0, anything to the power 0 will be equal to 1. Okay, therefore your x value is 0 and your y value is 1. Okay, that is, yeah, simply put, I think this is 1 mark. Oh, 2 marks. All right, 5.2.2. Calculate the value of a. Okay, so I'm just going to say y is equal to a to the power x. Remember, we have been given a point a, right, which is -1 and a half, and we're going to substitute that point, the x value, which is -1, and the y value, which is a half. Okay, we're going to substitute it in here. So y is a half and x is -1. Okay, if I write that properly, it will be 1 over a, and as such I can see that a is actually 2. Okay, therefore I can say I have I have 2 to the power x. All right, now 5.2.3. Write down the equation of the inverse function in the form using y. All right, so if I have y is equal to 2 to the power x, and because I'm looking for the inverse, I will swap x and y. And now because I need to write it in terms of y, I'm going to use my logs. So basically y is equal to log base 2, log x base 2. Okay, that's that. And then 5.2.4. So it says draw a sketch of the inverse. Okay, and indicate the coordinates of 2 points that lie on the graph. I'm going to draw the original. It helps me actually to draw the inverse as well. So just bear with me, please. All right. So this is my y-axis, my x-axis, and I'm going to draw the line y is equal to x, because that actually helps. So y is equal to x. So the original function, something like this, okay, which is h, and we have that point there where x is 0 and y is 1, and we have a, which is -1, as well as a half. Okay, now when we draw the inverse, let me just use a different colored pen. So the inverse will look something like that. It's not really symmetric. Anyway, you get the drift though. Let me not try to make it perfect. Okay, so over here, we're passing at 1, right? And that's 0. Y is 0 on the x-axis. And then further down, we have a half and -1. So we've indicated 2 points. Okay, hope that was good enough. Now 5.2.5. It says, read off from your graph the values of x for which log x base 2 is bigger than -1. Okay, remember this is where -1 is, right? There's -1. Y is equal to -1. So the x values from -1 going above. Okay, so basically x will be bigger than a half. Okay, do not do this because they just said where the function log x base 2 is bigger than -1. Okay, so this would be your answer. Okay, 5.2.6. Now, if g of x is equal to 100 times 3 to the power x, Determine the values of x for which h of x is equal to g of x. So this is where they basically intersect. So yeah, h of x, we said it is 2 to the power x, né? And g of x, it is 100 times 3 to the power x. All right, so what am I going to do? I see that I have the same power, so I'm going to divide by 3 to the power x both sides. And basically I have 2 over 3 to the power x is equal to 100. Now I need to solve for x. So x is equal to log, okay, I have a base of 2 over 3, 100. So basically log 100 base 2 over 3. And I'm just going to use my calculator there. So log base 2 over 3. And we have 100 over there. So we have negative 11,36. Okay, so yeah, that's how it is. If you're finding it difficult to see these functions, just type in Google and Desmos graphing calculator and just put the graphs there just so that you can see how they actually look together, because you have y is equal to 2 to the power x. Now 3 to the power x multiplied by 100, that's going to look different, okay? But ultimately, wherever they meet, they're going to intersect somewhere at negative 11,36, okay? I think the other one, geez, I'm not sure if it's like this or if it comes this side. Oh, yeah. But yeah, you can work that out and you can see how these graphs look. Okay, using Desmos. That's 5.2.6. Now 5.3. Actually, let me just get it for you quickly, Desmos, and let's see how it looks. So yeah, this is the graphing calculator, Desmos, and let's just look quickly how these graphs actually yeah, let's just see how they look. So we have y is equal to 2 to the power x. Okay, there it is. And then we have y is equal to 100 times 3 to the power x. Oh, okay. So this is how it looks. And then where do they intersect? See where they intersect? There, at negative 11,36. Okay, so that's basically what I wanted to demonstrate for you guys. Yeah, it helps to understand better. Okay, moving right along. So now we have the price P in rands per unit of each item in a consignment of Q items. Ooh, we're learning English here. What is consignment? Okay, and it's given by that formula. Okay, P is equal to log 10 plus Q over 2. Yeah. Now 5.3.1, it says calculate the value of P and the total price of the consignment when the consignment has 1,980 items. All right, so P is equal to log. Ooh, this one is waking up. Okay, 10 plus Q over 2. So we have, we want the value of P, right? The price, rands per unit. Okay, so what we have here is Q, which is the number of items. So we have 10 plus 1,980 divided by 2. I'm just going to put this into the calculator. So we have log 10 plus 1980 divided by 2. And we can see the answer is 3. Okay, so we have 3 rand per unit because they told us that the price is rands per unit. And they said the value of P, so we have the value of P. Now we need to also get the total price. Okay, so we have 3 rand per unit multiplied by 1,980 units. Now we can get the amount. So 3 times 1980. So there we have 5,940. Okay, please do not mind the snoring in the background. This is the only time I can record. Alright, so now it says determine the number of items in the consignment when the price of each item is 2 rand. Okay, so now we're looking for Q. Okay, because Q is items. So P is equal to log 10 plus Q over 2. So we're looking for, so the item is, 2 rand now. And then we have log 10 plus Q over 2. Okay, now, what are we going to do? So here, in the absence of a base, remember, if it's base 10, we don't really write it. It's just that thing that you must just know. So how can we rewrite this? Okay, remember when we have y is equal to log x base 2, what did we have initially? We had x is equal to 2 to the power y. So same thing here. We have 2 is equal to log base 10 and that. Okay, so I'm going to take our base there, which is 10. All right, and then so you see our base there, which is 2 to the power y. So basically 10 to the power 2 is equal to 10 plus Q over 2. Okay, I hope that makes things a little bit easy. So we have 100, which is 10 to the power 2, minus 10, we're left with 90. Q over 2. And then if I say 90 times 2, I have 180 items. Okay, and that's basically that for question 5. Now let's get to question 6. Okay, we're moving along quite nicely. Alright, so with question 6, we have there a straight line graph, okay, f of x, which is minus x plus 4, and then we have a hyperbola, or hyperbola, however way you pronounce it. Okay, so let's go to 6.1. So it says, write down the domain of G. Okay, so domain of G, basically the x values where G is valid, all right? And I can see by this x plus 1 that we cannot have x being equal to 1, all right? So all the other values of x are valid except for 1. Or you could have said x is an element of minus infinity all the way to minus 1. Also minus 1 all the way to positive infinity. Remember, we're not using closed brackets here because minus 1 cannot be included. All right, and then 6.2, write down the equations of the asymptotes of G. Okay, so basically, can I edit this? I think I can. Yes, I can. So basically, here at minus 1, I have an asymptote because I couldn't pass there. Okay, so the first one, x is equal to negative 1, and then y is equal to 2. Okay, let me just make this a little bit smaller. Or can I not edit it? Okay, there we go. So y cannot be also equal to 2. Okay, my line is not make sure, but yeah, there we are. Y is equal to 2, as well as x is equal to -1. All right, now how am I gonna pan? Let me just save it. Okay, let's go on to the next question, which is 6.3. It says calculate the coordinates of point D, a point of intersection of G and F. All right, so basically there, we know for A, they intersect at 4, right? Y is equal to 4. Now for D, where exactly do they intersect? I can see Y is 3 and X is 1 just by looking at it, just by visual inspection. But this is 5 marks, so I need to go and show where is Fx equal to G of X. So I have negative X plus 4 is equal to 2 over X plus 1 plus 2. All right, and then I am going to take 2 to the other side, so I have minus x. 4 minus 2 is 2. Okay, and then I have 2 over x plus 1. Now I'm going to multiply by x plus 1 on both sides. Okay, baby girl. All right, so x plus 1 multiplied by negative x plus 2 is equal to 2. Now let's just multiply out the brackets. I have negative x squared minus x plus 2x, and then plus 2 is equal to 2. So here I can already see that these two can cancel out, and then I'm left with negative x squared minus x plus 2. X is going to be plus x. Okay, that's 0. Let me just take x to the negative, to the other side. Yeah, let's just take everything to the other side. So I have positive x squared minus x. And then if I take out the common factor, I then have x minus 1. Okay. So then I can see then that x is equal to 0, yes, where we have y being equal to 4. So that's not the one we are interested in. We are interested in x being equal to 1. Okay, so our visual inspection was not so bad. We have x equal to 1. Now we can take any formula, f of x or g of x, and substitute 1. I think f of x is simpler. Okay. So let's see what happens then. I have minus 1 plus 4, and we can see then that y is actually equal to 3. So what is D ultimately? D is basically 1 and 3. Okay, and that's it for question 6. Question 7, financial mathematics. Okay, helping you prepare better for the future and know what to calculate in your finances once you start working, right? Or even now, you don't have to wait until you start working. But anyway, it says, at what annual percentage interest rate, compounded quarterly, should a lump sum be invested? So as soon as they say lump sum, think about the compounding equation, not the annuity. Okay, so should a lump sum be invested in order for it to double in 6 years? Okay, so we know for 1, the interest rate is compounded quarterly, and then we have a lump sum, right? And then that lump sum will be doubled in 6 years. Okay, and our unknown is the interest rate. So we're going to use our compound formula. A is equal to P, and then we have 1 plus I to the power n. Okay, so what are we going to substitute in the place of A? We're going to have 2x in the place of P, that is x. We're looking for our interest rate, which is compounded quarterly. Actually, n, we want it in quarters, right? So it's basically 24 quarters. So basically n will be 24. Okay, so now let's see how we can solve this. The x's are going to cancel. So I have 2. Okay, let's do this. Yeah. Root 24. And again, 1 plus I to the power 4. Root 24. So now I'm going to say, let me just draw a line here so that we're not really confused as to what's happening over here. So basically, I have 2 root 24, and then I'm going to subtract 1. Oh my gosh, this girl is snoring. And then we're going to multiply by 4, and that'll be equal to the interest that is charged. Okay. So then let's take out our calculators and see what we can do over there. So we have shift, and so shift, and that is what we're looking for. So we have 24, and then 2, and then minus 1, and we're multiplying that by 4. Okay, so what do we get? We get 0,117, 1172, and if we multiply that by 100, that will give us the interest rate in percentage. So that's basically 11.72%. Okay. All right. And then we get to 7.2. So Michaela buys furniture to the value of 10,000. Okay, she borrows the money on 1st of February 2023 from a financial institution that charges interest at a rate of 9.5% per annum compounded monthly. Michaela agrees to pay monthly installments of $450. The loan agreement allows Michaela to start paying equal monthly installments from the 1st of August 2023. That is very dangerous. If you're going to take out a loan, please start paying immediately. This thing of delayed payments is going to show you flames, because money doesn't sit still. Money is either growing or not growing, but it's never still. Okay, so she borrows money on the 1st of February. Okay, 2023. If she were to start paying immediately, she would have to start paying in March. Okay, so we have February, March, April, May, June, July, and August. Okay, so yeah, basically, okay, anyway, let's read. No, let's just summarize the other information. So the interest rate is basically 9.5% per annum compounded monthly, and the monthly installment that she agreed to pay is $450. And what else are we missing? What else? Oh, the amount that she borrowed, present value. Okay, present value, not PX. So that's basically 10,000. And N. Okay, but anyway, let's read the question first, and then I'll get to how we calculate N. All right, so it says, calculate the total amount owing to the financial institution on the 1st of July. So remember, this is June, this is July. So basically, 1, 2, 3, 4, 5. Okay, so our N then for answering this question is 5. Okay, so like I said, remember, money doesn't sit still. So she had borrowed 10,000 Rand in February. The banks are very happy to tell you that you can start paying much later on, because they know that 10,000 Rand 5 months later is not going to be 10,000 Rand. And that is why we need to calculate the total amount owing. Okay, and by that we're going to use the compound formula, not the annuity formula. It's a lump sum that's sitting there. Okay, so we have to use the compound formula. So there it is, to the power n. Now P in this case is 10,000 rand, because that is what was borrowed. And then, yeah, that's the principal amount. Then we have 9.5% compounded monthly, and it's 5 months, ne? Please don't think it's 5 years. Now you're multiplying the 5 by 12. Okay, so we have 10,000 and our brackets there to the power 5. And then we have 1 plus 9.5%. Yeah, there's the percentage sign, and then divided by 12. So at this point, it's no longer 10,000, but after 5 months, it's 10,402 rand and 15 cents. I'm going to save this answer, okay? I think it's safe to save it because we're probably going to need it somewhere. Okay, now 7.2.2. All right, so it says, how many months will it take Michaela to pay back the loan? All right, now remember our principal amount, the amount owed now, it's no longer 10,000, but it's 10,402 rand and 15 cents, okay? And because it's a loan, it's not an investment, we're going to use the present value formula. Okay, so we have 1 minus 1 plus the interest rate to the power negative n, and that is divided by the interest rate. So we have, what are we looking for again? We're looking for n, how many months it will take her to pay back the loan. So I'm going to try to write this equation in terms of n. So basically I'm going to have the present value multiplied by the interest divided by the monthly payments. Then I'm going to subtract 1. Then I'll be left with that negative 1 plus I. Okay, I think here let me just start substituting the values so that I don't mess myself up. So it's that multiplied by 9.5% divided by 12. And all of that is divided by x, which is 450. All right, and then minus 1. And then in there we have negative 1 plus the interest, which is 9.5% divided by 12 to the power negative n. Okay, so I knew I was going to need this answer. So I'm going to say that answer multiplied by 9.5% divided by 12 all over 450 minus 1. So that is negative 0.82. But we're keeping that answer in there, okay? I am going to store it as well as B. Okay, and then on the other side we have a negative. So I have 1 plus 9.5%. Where's the percentage? There it is. Divided by 24. So it's, I'm just going to use this 2419 because I don't want to lose the values there in negative n. So I have my unknown as an exponent. So I'm just going to say negative n. All right. I'm going to use logs. I hope you see. The base will be 2419 over 2400. And that's going to be equal to, oh, by the way, the negatives can cancel out. So I'm just going to put 0.82. Okay, so I'm going to actually go back to my value for B. It's negative, right? And multiply it by negative 1. And store it again. Shift store B. Okay. How? Alpha B. Yes, it's positive now. Okay, great. Now let me get what this log is. So I have log, and my base is 2419 over 2400, and Oh, I can just actually use the answer. So I have negative 25,63. I'm actually also going to store that just in case I need it. Okay. And yeah, where's the answer? Okay. But n, it's preferable that it's a whole number. Okay. So I will then say n is 26 months, since we're calculating in terms of months. Okay, so yeah, that's basically the months that it will take for Michaela to pay back the loan. Now 7.2.3. What is the balance of the loan immediately after Michaela has made the 25th payment? Okay, basically what they're asking for is, what is the outstanding balance? All right, remember with the outstanding balance, there are two formulas. I think I'm going to show it to you both ways. So I'm just going to say OB, outstanding balance. So basically it is your compound formula minus your future value formula. All right, and whatever it is that they're asking for, like they want after Michaela has made the 25th payment, so in the place of n, you will be putting 25. Okay, so that's the beauty with this formula. You just use the values as they need it. Okay, so remember here we have p that, and then we have to the power n, and then for the future value we have x 1 plus I to the power n minus 1, and that is all over I. Okay, so what is the principal amount? Remember, it grew, so it is 10,402. And then we have 1 plus the interest rate, 9.5% over 12 to the power 25, minus 450, 1 plus 9.5% over 12 to the power 25 minus 1, all over 9.5% over 12. Okay, so remember we stored it. Let's just check. Alpha A is, what is happening now? Alpha A, yes. So there we have A multiplied by 1 plus 9.5% all over 12, okay, to the power 25, and then minus, we have 450. Okay, I have two brackets there. That is to the power, I'll come back to what's inside. And we are subtracting 1. I just want to close that bracket before I forget it. So here we have 1 plus 9.5% all over 12. Whew. Here, if you make a mistake, you are doomed. 9.5% divided by 12. Okay, so we see that what is the balance of the loan after making the 25th payment? It's basically 282 Rand and 36 cents. Okay, that's one way of doing it. Another way of doing it is by using the present value formula. Okay, basically we have 1 minus 1 plus the interest rate, and we have negative n divided by I. So here the n, remember I said here this outstanding balance formula, you use it as it is. So if they want the 25th payment, your n is basically 25. On the other hand, if you're going to use the present value formula, you're going to have to work out the remainder of the time. So we know n is basically 26 months, but I'd rather we use 25.63 just to be safe. So 25.63, but we're going to have to subtract the 25 because we need to use the remainder of the time. Okay, I can't remember where I saved this. Was it alpha B or was it alpha C? Okay, I think it's alpha C. Okay, we need to multiply that by a negative 1. So 25,63 minus 25, we have basically 0,63. That is our n. Okay, so that's the difference between the two methods, but we should be getting the same answer. So basically, the outstanding balance, let me rather use OB again, outstanding balance, is basically equal to x is 450, right? And then we have 1 minus 1 plus 9.5% over 12 to the power negative 0.63. And that's divided by 9.5% over 12. Okay, so let's work this out. So we have 450. 450 multiplied by 1 minus 1 plus 9.5% all over 12 to the power negative, my answer. I like storing things so that they're not watered down, right? But sometimes it's not always possible. And yeah, there we go. We have the same answer. If I had rounded off, I would have probably been off there. Okay, so two methods work differently but should produce the same answer. And that's it for question 7. Now let us go to question 8. Whew, I feel like I'm rushing this paper, but yeah, if I'm rushing and you're not understanding something, please do comment below. I'll be happy to answer. But yeah, so far this paper is pretty much okay. I'm used to prelims being way harder, but maybe they're being lenient, or maybe they're gonna catch you in paper 2. I don't know, but let's just continue. So 8.1. This one from first principles. If f of x is equal to negative 2x squared plus 3x, determine f of x from first principles. So let me just go straight to it. So in your formula sheet, you'll remember this formula where you have the limit as h tends to 0, not x. So we have fx plus h minus f of x. They're making life a little bit hard for us because, geez, wherever you have x, now you need to substitute x plus h. So we have negative 2x plus h squared plus 3x plus h minus negative 2x squared plus 3x. And that is all over h. I'm just going to make space for myself. So the limit as h tends to 0. So I have negative 2. Now I have x squared plus 2xh plus h squared plus 3x plus 3h plus 2x squared minus 3x. Whew. Here you need to be careful as well that you do not make silly mistakes, because they will cost you. Alright, so now we have negative 2x squared, negative 4xh, negative 2h squared. Okay, and then plus 3x plus 3h plus 2x squared minus 3x. Okay, now it's time to cancel. So negative 2x squared and 2x squared cancel. 3x and negative 3x also cancel. And the values that remain actually have h as a common factor. So I'm going to take it out even now. Okay, so if I take out h, I'm left with negative 4x, negative 2h, plus 3. And that's all over h. And then the h's cancel. And then we have the limit as h tends to 0, minus 4x minus 2h plus 3. So if I substitute in 0 in the place of x, I'm left with minus 4x plus 3. Oh my word. This is so laborious. Now, if we're going to use the power rule, okay, if f of x, so this is how you check your answer. So you have negative 2x squared plus 3x. If you're going to use the power rule, you're going to say negative 2 times 2, which is negative 4x. 2 minus 1 is just 1, but we don't put it there. And then plus 3. So that's the answer. Okay, so we're cool. It works out. And now 8.2, it says given f of x, which is that, calculate f prime 9. Okay, so here, let's just rewrite this f of x in a way that helps us to use the power rule. So I have actually 3 over 2 x squared minus 24 times x to the power a half. Okay, so now I can get the derivative using the power rule. So 3 over 2 times 2, that's just going to be 3x, and then 2 minus 1, that's just 1. And then a half times 24, that is 12. And then x, a half minus 1 is negative a half. And at this point, I am then going to substitute 9 wherever we have x. Okay, and then I'm going to employ our calculator or deploy the calculator and work out what the answer is. So I have, okay, 9 to the power negative a half. All right, so the answer is 23. Okay, 23. Cool, and that is what, 5 marks. Okay, and then we have 8.3. So a function g of x is a x squared plus b over x and has a minimum value at x is equal to 4. Remember, our minimum and maximum values are where the first derivative is equal to 0. Okay, or simply put, we can do that. All right, and then the function value at x is equal to 4 is 96. So basically, if we have g of x, actually g of x where we have 4, that's equal to 96. All right, and now what does it say? It says calculate the values of a and b. Okay, firstly, let us just get g of x. Okay, so g of x is ax squared plus b times x to the power minus 1. Okay, now if we work out the, let's just put 4 there. So g4, I have a 4 squared plus b 4 minus 1, and that is 96, right? 96. And I have 16a, and I have a quarter b. I am just going to get rid of that 4. I don't like working with fractions. So what is 96 times 4? 96 times 4 is 384 over there. And then I have 16a, and then I have b. So that is my first equation. Now, let us see what is the first derivative. Okay, so I'm going to have 2ax using the power rule. 2ax minus b x to the power negative 2. Okay, so what I'm going to do then, I said, okay, so I have 0 because it is a local, it is a minimum value. It's a minimum value. So yes, it has to be equal to 0. And then that's basically where x is 4. So I have 2a times 4 minus b, 4 minus 2. So I have 8a, and 4 to the negative 2 is minus b over 16. So I'm going to multiply 8 by 16. It's 128. So 0 is equal to 128 minus b. So that's equation number 2. Now let us work it out. I'm going to say equation number 1. I'm just going to say 16a plus b is equal to 384. And I'm going to add it with equation number 2, which is, I forgot an a there. Yeah, 128a, minus b is equal to 0. Okay, I'm adding the 2. So what is 128 plus 16? Okay, since I'm adding, so I'm going to get what? 144. Wait. Oh my goodness. I'm seeing my error here. I did not multiply this by 4. 16 times 4. So 16 times 4, that's 64. So that should be, sorry about that, 64a. Okay, so even this should be 64a. Whew, yeah, ne? But anyway, at the end, when you get your answer, please substitute it back just to make sure that, yeah, you are getting the right things. Okay, so here we have 64 plus 128, and that's 192. 192a, and then b minus b, that cancels out, and then 384. So what is a? So 384 divided by 192, a is 2. And then you take this to any equation. I'm going to go with the second equation. So we're going to substitute a in 2. All right. So therefore, b is 128a. Okay, if you take b to the left-hand side. So 128 times 2. Okay, that's 2, yeah, 256. 128 times 2, yes, it's 256. So I get that b is 256 while a is 2. Okay, and that is question 8, and that's that. Let us go to question 9. All right, so question 9. It says the graphs of the derivative of g. Okay, so we went from a cubic function all the way to a quadratic function. And there's also a straight line, which is h of x, and they are sketched below. Okay, so the graph of g prime is a derivative graph of the cubic function. Okay, that's cool. Now it says the graphs of h and g prime have a common y-intercept at e. Okay, we see that. We don't know what it is, but it's fine. And then c and d are the x-intercepts of graph g. Okay, and then point A is the x-intercept of h, and point B is the turning point of our derivative function. Okay, and then line AB is parallel to the y-axis. Okay, great. So it tells us that A and B have the same x value. Now 9.1.1, it says write down the coordinates of point E Okay, if it wasn't for the straight line graph, we'd be struggling a bit there. So E is the y-intercept, okay? And with the y-intercept, we know that x is equal to 0. Ooh. So we write that x is equal to 0. So basically, if I have y is equal to 2x minus 4, I'm going to substitute 0. And we can see that y is minus 4. Therefore, E, the coordinates of E is 0 and negative 4. 9.1.2. Determine the equation of the graph of G in the form of y is equal to ax squared plus bx plus c. So they have given us the x-intercepts, okay, and we also have a y-intercept, and that will help us a lot. So if you have your intercepts, you can basically use this formula, x minus x1. Okay, for now we're going to substitute the x-intercepts. So we have minus 2, so minus 2, that's just plus 2, and then x minus 6. And now we're going to substitute the y-intercept. So the y-intercept is where x is 0. All right, so in the place of y, we put negative 4, and in the place of x, we put 0. Okay, so we have 2 times negative 6, that's negative 12a. All right, because we have a happy face parabola, we are expecting a to be positive. So we have a is actually equal to 1/3. And as such, we can then write out the equation in this form. So we have 1/3 x plus 2, x minus 6. And we're going to take out the brackets. So we have x squared, 2x minus 6x, that's minus 4x. And then 2 times negative 6, it's negative 12. And then finally, we can then, oh, they wanted y. So y is 1/3 x squared minus 4 over 3x. And negative 12 divided by 1/3, that's negative 4. Okay, and then 9.1.3. It says write down the x coordinates of the turning point of G. Okay, now remember, we have a happy face parabola, meaning our cubic function is also a happy face. Okay, and if these are the turning points, and this is the point of inflection, so you just take down those lines. Okay, so basically we now have our parabola. Okay, this being the x-intercepts and that being the turning point. So this is the turning point, that's the x-intercept, turning point, that's the point of inflection. Okay, so let's read the question again. It says 9.1.3, write down the x coordinates of the turning point of G. Oh, so this being G, this being the derivative of G. So the turning points or the coordinates of the turning point of G will be x is equal to minus 2 and x is equal to 6. Ne? Yeah. Yeah, right on the x coordinates of the turning point of G. Yes, we have minus 2 and we have 6. Cool. Now 9.1.4. So it says write down the x coordinate of the point of inflection of the graph of G. Okay, so the point of inflection is here. And remember, it's equivalent, the x coordinate is equivalent to the x coordinate of the turning point. So I'm going to get the turning point of g prime. Okay, so x there is minus b over 2a. And what is minus b? So I have minus 4 over 3 minus 4 over 3 divided by 2 times a, which is a third. So basically I have 4 over 3 divided by 2 over 3, which is just 4 over 2, which is 2. Yeah, only 1 mark. So yes, x is equal to 2. All right. And then 9.1.5. Explain why g has a local maximum at x is equal to negative 2. And you can see here, all right, we have our local maximum there, where x is equal to negative 2, and we have our local minimum. So this is our minimum, this is our maximum. Our maximum is at x is equal to 6. So they're asking, explain why g has a local maximum at x is equal to negative 2. So let's say we didn't know how the cubic function look. All we have is a parabola. Okay, we have a parabola there, and we have our x-intercept, and there we have minus 2, and there we have 6. Okay, so basically, if you have values, the gradient of, okay, so the gradient of your original function, your cubic function, it will be positive above the x-axis, and it will be negative below the x-axis. So we know that the x-intercept of the parabola is the turning point of your cubic function. Now, if you don't know, then if you have a turning point on the left side, we know that the gradient is bigger than 0. On the right side, we know that the gradient is smaller than 0. So if it's bigger than 0, it should be doing this. If it's less than 0, it should be doing that. So we see. And then if you look at 6 over there, so that's the turning point. No? On the left hand side, the gradient is less than 0. On the right hand side, the gradient is bigger than 0. So if it's less than 0, it means it's going down. Okay? If it's bigger than 0, it means it's going up. So this tells you that this is your local max, and this is your local minimum. I don't know how you're gonna write that down. How many marks? 2. Yeah, I would really comment on the gradients. Okay, I would even sketch this if need be, but yeah, that's basically, I don't know if anyone has a better way of explaining it, but please do state it if you do have a better way. Okay, now 9.2 says, what have we been given? We've been given h of x, so we have 4x cubed plus 5x. Alright, it says substantiate whether it is possible to draw a tangent to the graph of h that has a negative gradient. So this is a happy phase cubic function. It should look something like this, but will it look like that? So if it looks something like this, we have a positive gradient, negative gradient, positive gradient, right? But I mean, it would look like this if we had maybe, you know, 5x squared and 2x and, you know, and 2. But we don't have that. We only have 4x cubed plus 5x. Okay, remember all of these are gradients. Here your gradient is 0, hence we call it a stationary point. So looking at this graph, I know from experience that it actually looks like this. Okay, and if you look at this, the gradient here is going up, going up, going up. But let's say you didn't know that this is how the graph looked. Okay, how would you test it? You would go and calculate the gradient. Remember, gradient is getting the first derivative and making it equal to 0. So the first derivative, using the power rule, is 12x squared plus 5. Okay? Yeah, 12x squared plus 5. If you were to sketch this graph, it probably looks something like this. Very narrow. Okay, and this is your 5. Now, looking at 12x squared plus 5, do you foresee this graph getting anything negative? If you're going to use negative values, okay, you're always going to get a positive, because this negative value, you'll have to square it. That will give you a positive. So looking at this, no, sorry, I shouldn't have made that 0. I'm supposed to say m, that's your gradient. So looking at this, your gradient will never, ever be less than 1. Okay? Your gradient will never be negative. And because your gradient will never be negative, we can then see why we have something like this. Okay, you always have a positive gradient because of this x squared plus 5. Okay, so I hope that makes sense. And now we can move over to question 10. All right, make this a bit smaller. Okay, yeah, interesting paper so far. I hope you're enjoying this memo and you are learning and preparing for your finals. Okay, and please don't forget to like our videos as well as subscribe to our channel. Thank you for those who've been subscribing. We're almost there at 3,000 subscribers. So yeah, question 10. The diagram below shows the plan for a veranda which is to be built onto the corner of a cottage. A railing AB, CDE is to be constructed around the 4 edges of the veranda. It is given that AB is equal to DE, which is equal to X. Okay, at this point, let me just say it. So AB is equal to DE, which is equal to X. So this is X, né? And that is X. And then BC is equal to CD, which is Y. Okay. The length of the railing must be 30 meters. Okay, so basically, I have AB plus BC plus CD plus DE, and that's equal to 30 meters. Okay, AB is X, BC is Y, CD is Y, DE is X. So I have 2x plus 2y is equal to 30. Let me simplify it by saying x plus y is 15, or y is 15 minus x. I don't know if I'll need it, but yeah, I probably will. Okay, and then what else can I say? Remember, we're looking for the value of x and y for which the veranda will have a maximum area. So at some point, we need to get the area. So what is FE and what is AF? So if this is y and that is x, then FA should be y minus x. Again, if CD is y and AB is x, then FE should be y minus x. Okay, because I want to calculate the area. All right, I hope you're with me here. So I pretty much have this length and that length. Okay, it's y minus x. It's like a square. So the area then, I can say, is the big rectangle is y by y. Okay, that's fine. So basically I have close this. I have y squared, but I must subtract the smaller area here, okay, which is basically y minus x squared. Okay, so let me just simplify that. Y squared minus 2xy plus x squared. So I have y squared minus y squared plus 2xy minus x squared. Whew. So my area is 2xy minus x squared. But, oh yes, this is where this comes in. Y is actually 15 minus x. So my area in terms of x is 2x times 15 minus x squared. So I have 30x minus 2x squared minus x squared. So then I have 30x minus 3. This is what we want. If you can put it like this, you can get the maximum area. And how do we get the maximum area? We basically work out the first derivative and make it equal to 0. It's like a local maximum. So I then have 30 if I use the power rule, and I have minus 6x, and I make that equal to 0. So basically 6x is equal to 30. So x is 5 meters. Okay, so I have x. Now I need y. All right, so y we said is 15 minus x. So y is 15 minus x, which is minus 5. So y is 10 meters. Yeah, once you get an answer, just look if it makes sense. If it doesn't make sense, probably something is wrong. Okay, and then, yeah, that's it for question 10. All right, second last question, question 11. So it says, let A and B be two events in a sample space. Okay, so we don't know whether these events are mutually exclusive or non-mutually exclusive. But what they tell us is the probability of A happening, event A happening, is 40%. The probability of A or B is 70%. And the probability of B is K. Alright, now let's see. 11.1. For what value of K are A and B mutually exclusive? So remember, if A and B are mutually exclusive, we have something like this. There is no intersection. Okay, this is your sample space. Alright, so basically, for 11.1, we would say probability of A or B is equal to the probability of A plus the probability of B. And we know that the probability of A or B is 0.7, while the probability of A is 0.4, and that of B is K. So what is K then? It would be 0.7 minus 0.4, which is 0.3. Okay, I think that was straightforward. Now 11.2, for what value of K are A and B independent? So independence, remember, is the probability of A and B. So here we can't have mutually exclusive events. They have to be non-mutually exclusive. What do I mean by that? So let me just finish off the formula. Probability of A multiplied by the probability of B. So now the events are like this. Okay? And A and B is this intersection. Alright, in the sample space. And with our formula, we know that probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So if I were to write this in terms of probability of A and B, I would get that I have probability of A plus probability of B minus probability of A or B. So what is the probability of A? It's been given, it's 0.4. For B, it's K. A or B is 0.7. Okay, so now we can go back to our formula for independence, which is probability of A and B is equal to probability of A multiplied by the probability of B. So A and B, I have 0.4 minus 0.7, which is negative 0.3, plus K is equal to 0.4 times K. So if I take 0.4 K to the other side, it's 1 minus 0.4, so that's 0.6 K. And the 0.3, I take it this side. So now K is 0.3 divided by 0.6, which is half. Okay, so it's a half or 0.5. And that's it for question 11. And finally, the last question. Oh my goodness, then I can go and sleep. Question 12. So, the data obtained from a city's police department indicates that of all motor vehicles reported stolen, 80% were stolen by syndicates to be sold off, 20% were stolen by individuals for personal use. Of the vehicles presumed stolen by syndicates, 24% were recovered within 48 hours, 16 within 48 hours, after 48 hours, and 60% were never recovered. And then of those vehicles presumed stolen by individuals, 38% were recovered within 48 hours, 58% were recovered after 48 hours, and 4% were never recovered. Okay, this makes sense if you think about it. Okay, now it says, draw a tree diagram for the given information above. Okay, so basically, we are looking at vehicles being stolen. Okay, and they can either be stolen by syndicates or by individuals. And how is that spread out? So if it's sold by syndicates, we know stolen, it's 80%, and then by individuals, it's 20%. Okay, it makes 100, so that makes sense. Now by the syndicates, there are those who, 24% recovered within 48 hours. So within 48 hours, that is 24%, 0.24. 16% recovered after 48 hours. Okay, that is 16%, so 0.16. And then never recovered. That is 60%. That is a very high number. Now for individuals, so within 48 hours, okay, that is 38%. And put in the arrows. And then after 48 hours, that is 58%. That is quite a good number. And then never recovered. Never recovered. Okay, that is 4%, so 0.04. Okay, this is my tree diagram. Yeah, it would have been nicer if it was like this, and then 1, 2, 3, 1, 2, 3. But anyway, it's all good. You guys get it? Okay, so now second question. We're done with the sketching. It says, calculate the probability that if a vehicle was stolen in this city, it would be stolen by a syndicate and recovered within 48 hours. So stolen by a syndicate, we're going this route, and recovered within 48 hours. So there we go. Okay, so we see where how the probability will be. So probability of syndicate recovered within 48 hours. So now that's going to be 0.8%, 80% if it's a syndicate, and 24% recovered within 48 hours. Okay, so let's just use our calculator there. So we have 0.8 multiplied by 0.24 and that's 0.192, or you could say, if you want to put it in percentage, 19.2%. Okay, and then 12.1.3, I almost said the last question, but it's not. It says calculate the probability that a vehicle stolen in the city will not be recovered. So basically, never recovered. So if it's a syndicate, then it will never be recovered. But if it's an individual, that's what we have over there. Okay, so let's get back. So the probability of never recovering the vehicle, never recovered, okay, it will be 80%, so 0.8 multiplied by 0.6. Yeah, for syndicates, that number is very high. It's highly likely that you will not recover it. And then for individuals, it's 0.2 times 0.04. That likelihood is very low. So we have 0.8 multiplied by 0.6 and 0.2 multiplied by 0.04. So we have 0.488, or we can say 48.8%. Okay, and now on to the last question. Alright, so you have to choose a password for your new Facebook profile. The password must be in the format of that. So we have 3 spaces where that sign is any digit. Okay, so zeros are not allowed. So if it's any digit, it means I have to choose between 1 and 9. Okay, so I have 9 digits available to me because 0 is not allowed. And then the at, which has 2 spaces, is any vowel. Okay, so if it's any vowel, it's A, E, I, O, U. So from A to U. And you may repeat any digit. So repetition is allowed. But you may not repeat a vowel. So repetition not allowed. How many passwords can be formed? Okay, so the passwords that can be formed. Firstly, if the numbers can be repeated, then there are 9 numbers available to me. And if the alphabets cannot be repeated or the vowels cannot be repeated, I have 5 available. Then after I've used 5, then I have 4 available. Okay, so I have 9 to the power 3 times 20. And what is that value? 9 to the power 3. 9 to the power 3 multiplied by 20. So basically I have 14,580 possible passwords that can be formed. Okay, and that is it, ladies and gents. We are done with this paper. All the best for paper 2, and we'll meet again afterwards. And remember, I'm also doing my own memo. So if there's a disagreement that you have, please put it in the comment section, and we will both wait for the official memo and mark ourselves. Okay,